So now that we know the algorithm for box-to-box collision detection, let's put it to actual use. So what I'm going to do to demonstrate this is I've built a simple program that has 4 rectangles that are going to act as borders to our world. And basically I'm going to have this ball follow the mouse, so it's always going to be where my mouse is, and we're going to test to see whether we have collision on the screen or whatnot. So this is the way we're going to do this. First I need to create a vector 2f to represent the mouse position. Oops. And inside of our update code, I need to retrieve that mouse position. So I'm going to put this right here. Oh, this code is all in the wrong spot. I'm just going to move this up to load content where it belongs. And now that I've retrieved that mouse position and I'm actually I have the ability to use it, I'm going to basically set the ball's x and y coordinates to the same thing as the mouse position's x and y coordinates, and that'll have the ball following my mouse around the screen. And I'll demonstrate that in just one second. So we're going to say mouse position dot x is equal to, oh sorry, backwards there, ball dot x is going to be equal to mouse position dot x, and ball dot y is equal to mouse position dot y. Now we have to cast these to integers because the mouse is a vector 2f for float, but the ball x and y require integers. So we need to cast this to an integer. Just put that integer in front and surround it in brackets, and it will treat it like an integer. So we can actually demonstrate this right now as long as I use proper operators. And let me just move things over here. So you can see I'm going to move nice and slow because you're seeing things at 10 frames per second. And we have our border walls, and this is just following my mouse around. You see there's a little bit of lag because it's got to catch up, but basically it follows the mouse around fine. Now what we're going to do is we're going to test our ball against all the borders. And if we get collision, I'm just going to have some text show up that shows a collision. So in order to do that, I'm going to have a boolean. Actually, you know what? Let's create an integer. Let's say int collision state, and we're going to set it equal to a 0, which is going to be for none. So let's create a couple constants for this. Final int none equals 0. Final int top is equal to 1. Final int right is going to be equal to 2. Final int bottom is going to be equal to 3. And final int left is going to be equal to 4. And the reason why we're going to do this is so we don't have any magic numbers and we know what everything actually represents. In the very beginning of our program, there is no collision, so our collision state is set to none. So basically down in our draw code, after we've drawn all the rectangles, I'm going to draw some text, draw.text, gfx, and the text is going to be, we'll just say collision, and plus collision state. Did I spell it wrong? I did. Collision state. And let's just throw it at a random location on the screen. It doesn't really matter. Let's throw it at 0, 0, or 0, comma, I don't know. Well, I did create a constant to find where where that border is, so we're just going to put it at the border height, so that way it's always at the top of the border. And for the font, I have a message font already created, and for color, helper dot, let's say white, so it's easy to read, and transparency 1f. Now I only want to show this if the collision state is not 0. Okay, so if collision state is not equal to none. So we only want to draw the collision state if it's actually colliding with something. So now we actually haven't set that collision value. We have to do that up here inside of update. So we need to test our ball against all the different rectangles. So because we, for our purposes, we're only going to check one possibility at a time. It is possible that we are colliding with more than one of these rectangles at a given time, but you'll have to handle that logic within your program depending on how you want your program to operate. But we're just going to use an if-else if for now, just to get it simple. So basically I'm going to say if box collision of our ball and our top wall, if that is equal to true, then what we're going to do is we're going to set our collision state equal to top. Now we're just going to copy and paste this 3 more times. Change these all to else ifs. And just go with all the different directions. So we have top, we have right, we have bottom, and then we have left. Okay, so in theory everything should work, assuming all of our logic is correct. So we come over here. So now we don't have it setting it to anything else at this point. We could set, let's just break out of here for a second and let's do an else case. So if it doesn't find collision with any of those, oops, then we want to set collision state back to none. And then that should produce a much more useful effect for us. So that's the top, that's the right, that's the bottom, and that's the left. And you can see we can pass right through and it only shows a collision while we're actually colliding with it. So this can be very useful for a lot of different things that you're doing, whether that's making a shooting game or whatever you're doing, testing to see whether any 2 images collide, depending on what your game is. So that is box-to-box collision detection, and that's actually demonstrating it.